Hello everyone, I am Dr. Reshma KJ, Assistant Professor from School of Business Management, Christ, deemed to be University. Welcome to the course on Applied Research from Hypothesis to Structural Equational Modeling. In this session, we will focus on formative measurement models, which represent an important type of construct specification in structural equation modeling. By the end of this session, learners will understand the fundamental concept of formative constructs and how they differ from reflective construct. We will also explore the key evaluation techniques used to assess formative measurement models. These include assessing convergent validity, checking collinearity among the indicators, and testing the statistical significance of indicator weights. Understanding these evaluation criteria is essential to ensure that formative constructs are correctly specified and interpreted in research models. After completing this session, learners will be able to identify formative measurement models within a research framework. You will also learn how to evaluate their quality using several important assessment techniques. These includes redundancy analysis to establish convergent validity, VIF values to assess collinearity among indicators, and statistical testing of indicator weights to determine their contribution to the construct. Additionally, when indicator weights are not statistically significant, you will understand how outer loadings can be used to determine whether the indicators should still be retained in the model. Tetrad analysis is a procedure in which we can know whether our constructs are reflective or formative. The null hypothesis of this test is that all constructs are reflective. How does it test? It checks the correlation between the items one by one, 4 at a time. That's why tetrad. So the first two minus the second two standard deviation, so that it keeps subtracting and it assumes that it should come 0. The correlation should be near perfect, so that's why it's run. The perquisites are that it requires at least 4 indicators because, for example, the standard deviation of one first item with and second item minus that of the third and the fourth item, so that too much of variance is not there. Then all these results will become 0, like everything will be equal and it will become 0. So the tetrad would vanish. That's what we say CTA, null hypothesis, is that all items will be highly correlated and so the tetrad will vanish. But if there is no high correlation, then the results will be significant, and that means your null hypothesis will be rejected. And then you will conclude that your construct is formative because your items are not highly correlated. As we know, the reflective items will be highly correlated and formative items may not be highly correlated. But for that, you need at least 4 indicators. Any construct that does not have 4 indicators, then we cannot run CTA. And CTA is not compulsory to run at all. Actually, not at all required, because ultimately, theory is what should be given to support that you have a formative construct or a reflective construct. Then you might wonder, why are we discussing about CTA? If suppose you are making a formative index for the first time and you want to show that theoretically it is formative and also statistically confirm that it is formative, because this is confirmatory. This will not tell you whether it is formative, it will only confirm what you are saying. So, if you are saying it is formative and the CTA also proves that, then the results are like your p-value are coming significant, which means that is formative correlation of item is less so that you can support your results with CTA. So now let's see what all is required for the formative measurement model. The first thing that you note is in formative, there is no reliability assessment. Why? Because reliability measures are always based on correlation and informative measurement. We do not assume any correlation as we discussed. So, no reliability measurement is done in formative constructs. We start directly and with validity. We can evaluate the formative measurement model in 3 steps. Firstly, we assess the convergent validity of the measurement model. Secondly, we check for the collinearity issue. Lastly, we assess the significance and relevance of the formative indicators. Convergent validity simply means that you have asked the correct questions for that construct. For that, we follow a procedure called redundancy analysis. And for this, you have to have a global single item in your questionnaire for each formative construct that you are having. So, when you are actually collecting your data, you need to be very sure whether you are collecting it as a formative construct or as a reflective construct. And accordingly, you have to include a single item for each formative construct apart from the main items. So, let us say my main item for job satisfaction where that I am satisfied with my salary, I am satisfied with my work hours, I am satisfied with the career advancement that I am having, I am satisfied with the peer support, I am satisfied with my supervisor's support. Now there will be one more item which will say that overall I am satisfied with my job. Simple as that. An overall picture of that construct has to be captured in a single item, and that is why we call it a single global item, that it gives you a global picture, an overall picture of that construct. I will always ask one question related to the overall assessment of the things. Kindly refer to the paper Sarstedt et al. 2023 so that you can understand that what type of questions are considered formative, which type of questions are considered reflective. When evaluating formative measurement models, we have to test whether the formatively measured construct is highly correlated with a reflective measure of the same construct. This type of analysis is known as redundancy analysis. Redundancy analysis verifies that a formative construct created by a multiple indicator correlates strongly with a separate reflective measure of the same construct. A researcher includes a global item, a single direct question, in the survey alongside the formative indicators. In PLSM, this global item acts as a dependent variable, while the formative construct acts as an independent variable. To execute the process for determining convergent validity, one must plan ahead in the research design stage by including an alternative measure of the formatively measured construct in the questionnaire. From the example, we can see the results for the redundancy analysis for the ATR, that is attractiveness construct. The original formative construct is labeled with ATRF, whereas the global assessment for the company's attractiveness using a single item construct is labeled with ATTRG. As we can see, this analysis yields a path coefficient of 0.874, which is above the recommended threshold of 0.70, thus providing support for the formative construct's convergent validity. The redundancy analysis of CSOR, that is corporate social responsibility construct, estimates of 0.857. Thus, All formatively measured constructs exhibit convergent validity. The second step is collinearity. Why do we do it? Because collinearity means there is high correlation between the items. Now, for example, in our job satisfaction example, if I say that I have taken salary, I have taken career advancement, I have taken whatever work hours, and let us say I have taken peer support, superior support, and I have also taken performance appraisal. Do you think any of this 5 to 6 thing that I have spoken will come highly correlated? So, if I am taking one more variable which is actually reflecting the other 2 to 3 which are already there, then collinearity issues will come. And yes, they can come in salary and career advancement also. So, if they are coming, then I have to decide that which of these is more important. So, I need to keep that. Obviously, salary would be more important and job satisfaction. So, I will keep salary. I may remove career advancement. But so that is why collinearity has to be checked. If you have high collinearity, the VIF value will be greater than or equal to 5, and VIF value less than 3 would be very good and very ideal. That means there is no collinearity at all. Anything below 5 would be acceptable. That means there may be a little correlation, but that is acceptable. It is not something which will create problem. But anything above 5 will mean that there is very high correlation, because any one or two of your item, and in that case only one should be taken, because the other one is actually highly correlated to this first one. Now, which one you will take, that depends on the theory. Like whatever theoretically is more important, you will obviously keep that. So, treating collinearity issue means this only that you keep one of them and remove the other, and then see whether the results have improved, so we can move ahead. So now what you have to see is the significance of the outer weights. Once the collinearity issue is not there, that means we have not repeated anything which we should not have. So, significance and relevance of the indicator is the third step. In this case, you maybe have to run the bootstrapping. Now, in the second step, we will run bootstrapping. These results that I mentioned before, like VIF values, this is there in the PLS algorithm results. Only significance will come in bootstrapping results. So, we will run bootstrapping now, and then we will check that how much are the outlier weight coming. For formative, the outer VIF value should be less than 5. Ideally, it should be less than 3, otherwise less than 5 is okay. If the outer weight is significant, that means all the items that we have taken are significantly contributing to the contrast with. Basically means all are important and we retain them. If one or two items are not coming significant in weights, here weights means that the regression is running with all the items we have taken, and we are relatively checking these items. In formative construct, this regression running between items and construct, it's telling the relative contribution of each of the item. Therefore, if the outer weights of the item is not coming significant, it does not mean that the item is not contributing at all. It only means among the different items, that particular item is relatively less importance. Next, we have to check the outer loading of that item, that is the one-on-one contribution. And if the loading is above 0.5, we have to retain, because It says there is 50% correlation exists and the item is important even though relatively lesser than the other item in the study. If outer weights is not coming significant means relatively that thing is not important, but does that mean I should remove it? No, because I have to see whether absolute contribution is there. That's okay, relatively it is lesser important, but overall contribution will be there in the construct. So I cannot remove just because they are relatively insignificant. In that case, I have to check the outer loadings because loadings will tell me that one on one how much is the contribution. So this will be told by the loadings. If the loadings is above 0.5, then I should retain that indicator because that means at least 50% correlation is there. So that means this item is important even if it is less important than the other two or other three, whatever you are having. But we should keep it because ultimately in itself it is important. If the loading is also less than 0.5, then we have to check whether the loading is significant or not. If it is significant, then again I may keep it if theoretically I feel it is important. In reflective indicators, the easiest option is to delete that indicator because all the indicators are actually asking the same thing. So if you delete one or two does not matter. But in formative, it matters a lot because each item is asking a separate thing. So when you delete one item, you are actually deleting a part of that construct. So we need to be very careful. We cannot delete just because of certain things. If a relative contribution is not there, I will check the absolute contribution. Even if that is also not there, I will just check that is it less than 0.5. But is it significant? And if theoretically that thing is important, I will still keep it. But if it is not significant also and it is less than 0.5, then of course that means that indicator is not serving any purpose in your construct. Then you can delete it. So that will be the last option, that deleting. Let's summarize the session now. Formative measurement model are defined by indicators that cause or shape the construct rather than being caused by it. Convergent validity is established through redundancy analysis, where a correlation of 0.70 or higher with a reflective benchmark confirms validity. Collinearity among indicators is assessed using the variance inflation factor. Value below 5 are acceptable, while values of 5 or more indicates critical issues. The statistical significance of indicator weight is tested with significant weights interpreted in terms of their absolute and relative contribution. When weights are not significant, outer loadings are examined. Indicators with loading of 0.50 or higher are retained, while weaker indicators may be removed or deleted. Valid formative constructs require careful indicator selection management of collinearity and balanced interpretation of both weights and loading to ensure meaningful results. In the next session, we will have a hands-on session on the formative measurement model. Thank you and see you all in the next session.